Today we're going to work on dividing polynomials. And dividing polynomials can get really complicated, but we're going to stick with the easy version today, and we'll get to the more complicated stuff a long time down the road. So let's just do some regular division for a second. 4 times 6. 24. According to the rules of multiplication and division, I could also write this same situation as 24 divided by 6 equals 4. So every multiplication problem can be rewritten as a division problem. Would you agree? Okay. If I had 3x times 2x minus 8, how do I multiply those? I bring the 2x into both. That has a name. Do you remember what it's called? Distributing. So if you have something multiplied into a polynomial, you distribute. That multiplication goes into every single term. So 3x and 2x turn into 6x squared, right? And 3x times negative 8 would turn into negative 24x. In theory, I should be able to put that up here and say 6x squared minus 24x, and I have a multiplication problem that equals a product. I should be able to divide. Just like 4 times 6 is 24, I can say 24 divided by 6 is 4. So if I took my product, 6x squared minus 24x, and divided it by one of my factors, 3x, I should get what for my answer? 2x minus 8. Does everybody understand the concept there? It's sort of like saying 4 times 6 equals 24. So I should be able to rewrite that as 24 divided by 4 equals 6. Okay. So how do you divide polynomials? Well, when you distribute, you take this monomial and you hit it with both of the terms on the inside. So now we're just going to go backwards. I'm going to divide these, and when I'm done, I'll divide these. So the first two, what is 6x squared divided by 3x? So let's think of it this way, 6 over 3. What is 6 over 3? 2, which is what I have right there. And then, what about x squared over x? Well, I have x on top, that's x squared, and a single x on the bottom. And what is x divided by x? Just equals 1. We can just cancel those out and make them a 1. So we're all right to get rid of one of those, and I'm just left with x, which you see right there. Okay? All right, now we do the other set. What is negative 24 divided by 3? Negative 8, and x divided by x is just 1, and 8 times 1 is 8. So this is the correct answer. All right, let's look at a bigger polynomial. 15x to the third minus 12x squared plus 3x. Let's divide that by 3x. What do I get when I divide the first term by 3x? So 15 divided by 3 is 5. X to the third divided by x? X squared. Does everybody understand that? Okay. And then negative 12x squared divided by 3x would be negative 4x. What about 3x divided by 3x? 1. It's not 0, it's 1. Which is a little bit weird. What is nothing according to addition? What do you add to do nothing with addition? So if I said 4 plus something equals 4, what number does nothing for addition? 0. That is called the identity. The identity is the number that doesn't do anything, but the identity changes depending on what you're talking about. Is there a number I can multiply by and do nothing? 1. So 0 is the additive identity and 1 is the multiplicative identity. So when you say 3x divided by 3x is nothing, you're sort of right. But nothing, according to multiplication, is the number 1. That's the number that doesn't do anything. So 3x over 3x is 1. That is the correct answer. Okay. Sometimes when we do addition or multiplication, it doesn't work out so easily. For instance, 24 over 15. Can you divide 24 by 15 evenly? No. It just doesn't work. But can we simplify 24 over 15? How? 3 goes into both of them. So 24 divided by 15, let's take a 3 out of each of these. 24 divided by 3 is 8. 15 divided by 3 is 5. That is a simplified version of 24/15. Okay, we can do the same thing with polynomials. So let's say 36x to the 5th over 24x to the 3rd. How does that simplify? And I heard 2. Let's use 2 because I think it's a good thing to remember. Let's divide it by 2, which gives me 18 and 12. What about the x's? X to the 5th divided by x to the 3rd. X squared. Now I look at the result. Is that in simplest form? Do 18 and 12 have any common factors? 3 or 6 is actually the biggest one. So if I pull a 6 out of this, then I end up with 3x squared over 2. Could I have gone straight from the original to that? Yes, you have to divide by what's called the greatest common factor. What's the biggest number that goes into 36 and 24? 12. So if you divide it once and you don't get the smallest answer, you can always divide it again. It's best to look for the greatest common factor, but if you don't know it or if you mess up, you can always look at the result you have and simplify it again. Okay? What about this? 18x to the 5th over 36x to the 9th. What's the biggest number that goes into both 18 and 36? 18. So if I take an 18 away from 18, what am I left with? 1. If I take an 18 out of 36, what am I left with? 2. What about the x's? I have 5 on top and 9 on bottom. So if I write that out, 5 on top, 9 on bottom, and I start canceling. This one cancels that one. This one cancels that one. And those 3 cancel those 3. What am I left with? X to the 4th, but where is it? It's in the denominator. Can I put x's in the denominator? Yeah, you can. So this answer would be 1 divided by 2, x to the 4th. Does that make sense? So sometimes you do polynomial division and you end up with leftovers in the denominator instead of the numerator. Okay? So turn your papers over. I want you guys to try this one on your own. Just write this down. So I'll give you a minute. I'll pause the video, give you a minute to work on that, then we'll finish it together. If we look at each one of these separately, 12x to the 5th divided by 6x squared. How many times does 6 go into 12? Twice. And how many times does x squared go into x to the 5th? X to the 3rd times. 5x is on top, 2 on bottom. You line them up, you start canceling. There are 3 left, and they're in the numerator. Everybody all right with that? The next one, negative 36x to the 4th divided by 6x squared. Negative 6, and x to the 4th over x squared is x squared. Okay? 18x to the 3rd divided by 6x squared. 3x. And the last one's a little bit tricky. Negative 21x squared over 6x squared. Obviously, the x squareds cancel, so we have no x's left. And negative 21 over 6. 6 does not divide evenly into 21. But we can simplify. 3 goes into both 21 and 6. So if I pull out a 3, I'm left with 7 halves. Does that make sense? Okay. Everybody good? As good as can be expected? Let's try one more before I cut you loose. Oh, let's say, what should we do? Let's not do 15. Let's do... Sorry, guys. There we go. And we're going to divide this by 10x. And we'll just work this together. So for the first one, 5x squared divided by 10x. So the x's come out. One of the x's come out. 5 over 10. How does that simplify? 1/2. 5 is exactly half of 10. So when I divide this term by 10x, I end up with x on top and 2 on bottom. Does anybody not understand that? So 5xx and 10x. The x's cancel. Where is the x? Where's the extra leftover x? It's on top. And then both 5 and 10 are divisible by 5. This one turns into a 1, and that one turns into a 2. So 1x on top and 2 on bottom, or just x over 2. Okay. For the next one, negative 30x divided by 10x. Negative 3. And the last one, what do you do? 40 divided by 10x. What does 40 over 10 simplify to be? 4. And there's an x left over. Where is it? On the bottom. So that is the answer. All right, can you handle that? Okay, good luck.